This is problem 2 from practice quiz 7, and as I read this problem, I will be extracting information that is relevant for the problem. And so the problem states, Fun Times, a preschool, is interested in generating positive publicity for itself. Fun Times wants to say that children who previously attended their school now scored higher on first grade math test scores than first graders who did not attend their school. So here we see that they're trying to make a distinction between students who attended their school and students who did not attend their school. So Fun Times in essence is the treatment. Additionally, we see here that they want to make a distinction, a very clear distinction, that first graders who went to their school scored higher than those who didn't. So here we see a direction. Which is increase. They believe that students who attend their school would have an increased math score or test scores. The next section says, this preschool randomly selects 25 first graders who previously attended Fun Times. This 25 is our sample. And from the sample, we know n is 25. And it says, they find that these 25 graders averaged a score of 87 on the state math test with a sum of squares of 1536. So here we have two informations. We have M, their average, which was 87. And we also have their sum of squares, which is 1536, which will help us eventually get to standard deviation. Finally, Fun Times compares this with the average for all first graders in the state, mu equals 81. So there's our population information. And we see that mu equals 81. Help Fun Times determine whether their first grader scored significantly higher at an alpha level of 0.01. Again, here we see significantly higher. We already identified the direction to increase. But the last piece of information from down here is our alpha level, which is 0.01. So I'll put it over here. Now I'm going to attempt to address question A and B, which I've placed up here. And A says, which test would be the best to use, hypothesis test or t-test? In this case, the first question we want to ask ourselves is a population standard deviation provided. And if we look down here, all that we were able to get from the population was a mu with no standard deviation. Since we don't have the standard deviation here in the population, we cannot do a hypothesis test, and so we have to do a t-test. The second part, B, says this test should be a one-tail test or a two-tail test. Here we're going to focus in on the direction. We did find a direction which was to increase, a very specific direction, and therefore this is going to be a one-tail test. Okay, the next question, C, says write the null and alternative hypotheses in notation. I'm going to start off with the null, and my null is always h, 0, colon, and mu, and putting in the treatment, which is Fun Times. Now because this is a one-tail, I have a specific direction, which is to increase. In the null hypothesis, I always want to say that it will not increase, that it will either stay the same or the opposite of increase is to decrease, so it'll be less than. And always in reference to my original mu, my population mu, which is 81. So I'm going to write 81. So in essence, what I'm saying here in my null is that if all preschool age children went to fun times, the population average on this math score would stay at 81 or be actually less than 81. With my alternative, I'm going to be in alignment with my direction. So here I'm going to say H1 colon mu fun times will be in alignment with my direction to increase, so it will be higher than 81. So I will see greater than 81. Question D is asking me to draw a graph and shade the critical regions and to identify and label any z-scores or t-values. So in this case, we're using t-values since we've already identified that it's a t-test. So I'm going to first draw a graph here. And it wants me to shade the critical region. So to shade the critical region, I need to know my alpha, which is up here. I also need to know my df, and I can figure out my df by looking at my n, which is 25. So right next to that, I will write df equals 24, as df is n minus 1. So there's my df. And finally, I also know we identify that this is a one-tailed test. So knowing those 3 pieces of information, I can now calculate my alphas t by looking at our t handout. I find then that my alphas t is 2.492. And because my direction is to increase, this alpha t is a positive, and only the positive. So I will go ahead and label that here, positive 2.492, and I will shade the critical region here. Finally, question D. I believe this is question E. Sorry about that. Question E indicate whether there was a significant increase with statistical notation. And what I need to find here is go through finding my estimated standard error, my sample t, and locating that sample t. So the first thing I'm going to look for would be SM. And the equation for that is S over the square root of n. Now remember, right now we don't have S. All we have is SS. And so to find S, we can use the variance equation, which is SS over df. And now this is my variance equation. And what I do to variance is take the square root. And so I would have 1536 divided by 24, and I would take the square root of that. And that would actually give me my standard deviation. You should find then that when you do this, you should get an 8 for S. And so now that I have my S, which is 8, I will plug it into my SM equation. And so now I have 8 divided by square root of 25. And I have 8 divided by 5. This comes out to 1.6. That's my SM. Now I can figure out my samples t with m minus the mu over SM. M is 87 minus 81 over 1.6. This comes out to 3.75. So this is my t. and this is positive. So now what I'm going to do is locate this t on my graph. I'll estimate it to be somewhere over here. So this is the sample t, which is this one over here, positive 3.75. It landed in the critical region, so we accept the alternative and reject the null. And I'm going to write my results up here above the graph, and I'm going to say t, and in my parentheses I write my df, which in this case is 24, equals my sample t, which is positive 3.75, comma, p in this case is less than my alpha, which is 0.01. And the way I know that it's less is because it landed in the critical region, or I can make a line down here and start shading this way, and that blue shade is less than my red shade. And so to answer the question, yes, fun times does significantly increase test results, at least in math, than the average state population of first graders.